Okay, so today will be our last lesson on quadrilaterals, and we're specifically going to be talking about them in the coordinate plane. So in order to talk about quadrilaterals in the coordinate plane, we have to recall some of our um, formulas from earlier this year. So slope, distance, and midpoint are going to be a few things that we're going to have to use. So at this moment, I'd like you to take some time and see if you can figure out what the slope, distance, and midpoint are of the points PQ, where P is 4, -2, and Q is -2, 1. So I would like you to please pause the video and go ahead and fill out what you know and then see if it matches what I have on the board as well. Okay, so if you had went through and solved for all three, you would have found the slope to be -1/2, the distance to be 3 square root of 5, um, or the square root of 45. I just simplified the radical there. And then the midpoint as 1 comma -1/2. I used the formula for everything. Remember, for slope, you could have also used a graph or a chart. For distance, I use the chart method and then a squared plus b squared equals c squared. You could have also used the distance formula. And then for the midpoint, again, I use the formula because I'm a formula person, but I'm sure most of you probably used the checklist and you slashed off, which is perfectly acceptable. Okay, as long as you had gotten those three answers. Now, the reason that we need to know the slope, distances, midpoint is because the slope is going to help us check um, to determine if something is parallel or perpendicular. So we again have to recall what it means to be parallel and what it means to be perpendicular. To be parallel means they have the same slope. So if they have the same slope and they have one set of lines that have the same slope, we're going to have a trapezoid because remember they have one set of parallel lines. If they have two sets, it means we're going to have a parallelogram. Now remember, a rectangle, rhombus, and square are also considered parallelograms, so they could also be underneath of this large window of parallelograms. So remember, we still have rectangles, rhombus, and squares. There, okay? We can't forget those. And then if we have something that's perpendicular, which are opposite reciprocals, um, we're either going to have that rectangle or square, or if we're looking at the diagonals, it's going to be the rhombus. Remember, opposite reciprocals means we're negating whatever number we have originally. So if it was 1/2, if we negate 1/2, that's going to be negative. And then we flip the top and the bottom, just to recall that. So if we're looking at the distances, we're checking for congruent sides or congruent diagonals. Okay, if it has all four congruent sides, we're either going to have that rhombus or square. And then we have to determine are there right angles for the corners that they make, or they're not right angles. So that's how you determine between the rhombus and the square there. If opposite sides end up being congruent, but the other ones are not congruent to each other, then you either have the parallelogram or the rectangle, and again, then you're going to look at the slopes of those lines and where they connect and determine if there's that right angle or not. Lastly, we have that midpoint, and it's going to check for segment bisectors. So we're going to be looking for where we're cutting things in half. So that might help us there with determining the rhombus and things like that. Okay, I actually have a flow chart there in your notes, and this is going to be how we go through and determine what shape we're trying to find. So the first question we ask are both opposite sides parallel? Remember, if our answer is yes, we already know that we're going towards the parallelograms. And then we have to determine which of the parallelograms we're looking at. If we say no, then we're going towards probably a trapezoid or maybe not even a special quadrilateral at all. So we're going to follow the yes pattern first, and then we're going to go the no pattern. So if we go yes, our next question is, are our adjacent or intersecting sides perpendicular? If they end up being perpendicular, remember that means we have that right angle being formed. So we're either looking for the rectangle or the square. And then we ask the question, are the opposite sides congruent? If two pairs of the sides are the opposite sides end up being congruent, okay, then you have the rectangle. If all four sides end up being congruent, then you have the square. Okay, now if we had gone up and we found that opposite sides or their slopes were not perpendicular, we would have said no, and we would have said our opposite sides congruent. So our two pairs of the opposite sides congruent, right? Parallelogram. Or all four of the sides congruent, then you have the rhombus. Okay, now let's go back up to the top. If both sets of opposite sides are parallel, and we said no, so we go there, and do we have at least one set of opposite sides that are parallel? If that's true, then we would keep going down the flowchart. If it's not true, it means we just have a quadrilateral. We don't have any of the special ones. But if it's true, we would have had, are the non-parallel sides congruent? If they are, we have that isosceles trapezoid. If they're not, we just have the trapezoid. So let's look at an example of what type of questions we might be looking at. So our example number 1 says that quadrilateral ABCD has the coordinates 4, 7, 9, 7, 6, 3, and 1, 3. So my first thing that I'm going to do is to construct the actual shape in my coordinate grid because I want to see what it's going to look like. So I have, let's do green. I have 4, 7. That's my A. And I have 9, 7. B. 6, 3. C. And 1, 3. D. Okay, pretty much looking at that picture, I can tell that it's not going to be a rectangle or a square, right? So that means I'm probably thinking parallelogram or rhombus, but I'm not sure. I have to double check. So the first step is to find the slopes of each side. And again, you can find the slopes of each side by just counting there on your graph. If I'm going from A to B, right, and I'm looking for the slope of that, that's clearly not moving at all. So it's actually got just a slope of 0, right? And DC also has a slope of 0 because, again, it's not moving up or down. It's just going flat. So the car is just driving flat. Now, I do have a slope on AD and BC. So the slope of AD, I'm just going to go over here. I'm just going to count. Right, I went up 1, 2, 3, 4, and I went over 1, 2, 3. Okay, so I went up 4/3. Okay, and I'm going to count the same thing from C to B. So I went up 1, 2, 3, 4. I went over 1, 2, 3. So again, from B to C, our slope was 4/3. So now we can see that both opposite pairs do have the same opposite slopes. So that means we definitely have a parallelogram. So that's right now what we're thinking. It's some sort of parallelogram. Okay. But that means, again, it could also be a rectangle, rhombus, or square. Um, but looking at the picture, probably not the rectangle or rhombus. But we're going to check that. We're going to find the length now of each side. So I'm thinking it's going to be a parallelogram or a rhombus. So I'm checking to see if all the sides are congruent or if just two of the sides are congruent. So if I'm looking for the distance from my no slope lines, those are pretty easy because I can just count those. So the distance of AB, okay, looking at AB, I can just count that it's gone over 1, 2, 3, 4, 5. So that one has a length of 5. And I can count the distance from DC, and it also has a length of 1, 2, 3, 4, 5. Okay, now on the other ones, I would indeed have to use my distance formula. And you can see that I already have my values there for A and B when I did my slope. So my distance for AD is going to be 4 squared plus 3 squared equals my C squared. So 16 plus 9 equals C squared, or 25 equals C squared. Take the square root, and we're left with the value being 5. So the distance of AD would have been 5. And remember that BC also had the 3, 4. So the distance of B to C will also be 5. So all of our distances were exactly the same. And if we're looking for a shape that has all of the same sides, it's not specifically the parallelogram, but it is the rhombus. So there our answer would be rhombus. Okay. Again, we could look at that picture and tell that it was not a right angle. So there's no way it could have been a rectangle or a square. Our last example here for your notes, they've given us a parallelogram. They're telling us that it's a parallelogram. Remember that means the opposite sides have the same slope. And A is at 2, -1, which they've graphed for us. B is at 1, -3. C is at 4, -1. And they want us to know or tell them where D would be in the first quadrant, because there's actually 3 different points that we could plot on there, but they're telling us they want the one that's in the first quadrant. So we're going to find the slope. I'm going to take the slope from A to B and then apply that slope to C. So if I'm going from B to A, I've gone up 1, 2, 3, 4, and over 1, 2, 3. So I went up 4 over 3. So I'm going to go up 4, 1, 2, 3, 4, and over 3. 1, 2, 3. And there would be my new point for D. Now again, they told us in the first quadrant. If they had asked for a point or any point that could have worked, we would have to go through and find all of the points. So that was the first quadrant. That was answering this question. Okay, so answering this question, our answer would have been 1, 3. Okay. Now, if we were looking for them in the other quadrants, I'm going to use a different color. Okay, I'm going to actually count my slope from C to B. So I've gone down 1, 2, and over 1, 2, 3. So I'm going to do the same thing from A here. So I went down 1, 2, over 3. I'm going to go down 1, 2, and over 1, 2, 3. And that could be a new possibility for D there. Okay, and then I could do the same thing. Use another color. So if I, again, the slope from here down would have been 4 over 3. So if I went down 1, 2, 3, 4, and over 1, 2, 3, that would be another possibility there for my point. So notice there I have 3 different choices to where D would have made some sort of a parallelogram. Okay, so make sure you're aware that there aren't just one option. There are 3 there. If you have any questions, please write them on the sides of your notes and I can take care of them in class.